you can tell that it says that 1, this is for 1. Okay, 1 contained this much tons of sugar. There are 9, so you're going to times it by 9. But don't forget, you want to convert it into improper fraction. 25, 24. 6 times 4 is 24 plus 1, 25 over 6 times 9, right? You want to cross cancel. When you times 9, you want to put it over 1 if you can. It's placeholder. 3 can go into 6 2 times, and 9 3 times. 3 times 25 is 75 divided by 2. 75 divided by 2. Don't forget they want it as a mixed number. So 2 can go into 75 how many times? 2 can go into 7, 3, subtract 1, 37, and 1 half. 15 here, sorry. So let's put in 37 and 1 half. You're okay with the work? As long as you can actually don't see any error that I've made. So it's, oh, all right, sorry. 37 and 1 half. And that's a mixed number form. But try to also skim for or scan my work to see if there's any error I made, okay? Okay, good. You okay with this one? Yeah, it's just, you just need to write it out a little bit and make it neat, right? Divide. Okay, so you flip-flop and multiply, right? Okay, let me write it out. Okay, how about this? I'll let you catch my error. Oh yeah, okay, I'm glad you're doing the work. I'm glad. Okay, flip-flop. The 9 and 12 can be cross-canceled. Are we doing? Oh, it doesn't say you have to convert it back to a mixed number or anything. I got 21 over 8. Hey, those few problems, the number 1 and number 2, the rate problems, they are actually very important. My student, the next year up from yours, he has been working on that quite a bit, tremendously. So you're gonna have to actually master that. It will be great that by the time you get there, you shouldn't have any problem. But they're introducing it. Okay. Yes. What we got?
I'm gonna go. Can I go grab some
Okay. Yes.
tissues
Yes.
real quick?
Yes. Go ahead. Go ahead. No worries, Noah. Okay. So you do have, this is a rate problem again. A construction crew just finished building a road, right? The crew worked for 11.5 days. If they built 2.8 kilometers of road each day, this is the rate, kilometers of road each day. Find the total length of the road they built. Obviously, you multiply. Okay, so 28, 2.8. Yeah, you can use the calculator here. Oh, let's see what we got. Great. Okay, now they're actually trying to have you learn more about the rate instead of like something per day, something per hour. They're actually now, you'll see, they're making you do a ratio like 7 candies to I don't know. I'm making this up. For 8 cents. I'm making this up. Anyway, okay. So notation one, you you want to write it this way. Anything. Oh, let me lay out the format. A number and with the word two, another number from left to right. You can write it as this is the okay. Then I'll make it. I'll call it A and I'll call it B. Okay. In math, they use letters to substitute numbers with numbers, right? So if you ever see this arrangement, you can write as a fraction. This is one way of doing it. Okay, here's one answer right now as a fraction. Notation one, this is it. Notation two, you can write it as A and then colon B. So this is the second notation. So let's fill in the A. It's going to be 7. Exact same order from left to right. Okay. And then, yeah, there you go. All three are the same. The word two, the fraction, and the colon. Okay, so find the area of this rectangle. You remember, right? Like a rectangular shape or a square, you times side by side, side times sides. Let me erase this. Side times side. So it's going to be 4/7 times, I'll do a dot, okay? 2/3. Just multiply straight across, but your units is square feet. Okay, yeah, they gave you the unit. So, okay, multiply straight across. There's no cross canceling, so we're going to have to do that. So it's 8/27. All right. Yeah, 21st. Sorry. Good. Okay, write your answer as a mixed number in simplest form. Okay, so we have to multiply mixed numbers. So I think you were taught to convert each one into improper fraction first, right? Okay, so the first one, 3 times 2 plus 1. 3 times 2 is 6 plus 1 is 7. Over 3 times, I keep the x symbol, 4 5/2. Okay, multiply straight across, 35. Yeah, 35 over 6. 6 can go into 35 how many times? 5. And the remainder is 5/6. Yeah, the remainder is 5 and over 6. Same denominator. Okay, good. Okay, Bill is riding on a bike course that is 95 miles long. It's tiny. I can still read it though. I should have a magnifying glass. Don't worry, don't worry. So far, he has written 38 miles of the course. Okay, what percent of the course has Bill written so far? Okay, so normally you do, partial over total, like part of the total, right? The numerator would be like partial, and the partial seems like, let me see, whatever's implied total, it says that the writing course is that much long. Okay, I guess you can use the calculator. So it's 38 divided by 95 times 100. Okay, so let me see, let me check it. It should be 38 over 95. It's implying that's like the total length, the miles, right? Long. 38, yeah. Wait, let me read it carefully. It's written that much. Okay, yeah, that's sometimes they ask you what's the remainder. This is exactly what they're asking, what has been written. Written. Okay, so let me see, times 100 if you want it in percent. Okay, times 100%. Let me see my calculator here. You can punch it in if you want. So 38 divided by 95 times 100. 40%. Okay, adding. This is great because you guys are always going to come across everything that you've done so far, including the rate next year, the rate problems. Okay, common denominator. Is that adding? Yeah. What is the common denominator, Noah? Between 4 and 7?
Uh,
You remember? Okay, so if one number, well, there's a methodical way that you list them, but let's do it the way like a lot of people would do. Okay, college students would do. It's faster. You want to look at the bigger number. If the bigger number can be divided by the smaller number, that will be the common denominator. But if that is not the case, you just multiply them. So 4 times 7 is going to be your common denominator, but it's an LCD, least common denominator. So it's 28. That means you have to make them common, right? So times 7, whatever you times in the denominator, you times in the numerator. You might recall that. Times 4 times 4. Just clean it up. So it's going to be 21 over 28 plus. I feel so bad hearing it. 24 over 28. Now that you have common denominator, you add the numerators, right? But then you have to reduce it. What is that going to be? 45 over 28. Now, let me see. We don't have to convert it into a mixed number. It doesn't say, but you can still reduce. It's a simplest form that means if this is reducible, you have to reduce it. So, what number can divide into 45 and 28 at the same time? If you're not sure, you can prime factorize it. Now I'm showing you everything just in case you have to do it perfectly, right? 45, 2 times. Yeah, list all the factors of 45. How about that? Let's do it like that. No. I'm gonna do 45 prime factorize it. I'm gonna do 5 times 9, 3 times 3. I'm gonna do 28 here. 2 times 14, 2 times 7. Now, none of these are the same. All prime the factors of each number. There's none. Had it been anything of the same, you can cross cancel. Well, let me show it to you right now. So the answer is done. It's 45 over 28. But let's pretend that you were to show the work. See, nothing can cancel here. But that means you have to leave the answer as is. There you go. I'm glad we don't have to convert it into a mixed number. So that's even more tedious, right? Because it's not a word problem. If it were a word problem, so you likely have to convert it back. So you have to know, like, hey, about what number that is, the answer. Okay, let me see. Suppose that the hot dogs comes in a pack, in this pack of 10. Okay. And buns comes in a pack of 6. Bob bought the same number of hot dogs as buns. Okay. It was the least number of each for which, thank you, this was possible. Answer the following question. Okay, let's see. How many packs of hot dogs did he buy? Okay, all right. What do you think? Hot dogs came with in a 10. The buns
oh,
in 6. How many packs of hot dogs did he buy? Well, I think. Okay, I'll let you. Why 3? Can you tell me?
well, hot dogs come in packs of 10,
Uh huh.
and it says, um, it, never mind.
Okay. How many packs of hot dog did he buy? Suppose the hot dog comes in a pack of 10. A pack of 10. This is grammatical, right? Just read it like you're reading a book and don't think too much about it being in a math problem. Suppose the hot dog come in a pack in packs of 10 hot dogs, packs of 10. How many packs of hot dogs? Shouldn't it be 10? But try to think about it too, okay? I may not be reading it correctly. Also, what do you think? Okay, look at the second one. How many packs of buns did he buy?
6.
The buns, how many packs of 6? So it's likely that they're just having you brainstorming what, you know, the details, right? So try 10 and then 6. And then how many hot dogs did he buy? How many hot dogs did he buy? The total number of hot dogs. So Bob bought the same number of hot dogs as buns. Hot dogs as buns. Oh yeah, that's a little confusing. I think it's a trick question. It should be like it shouldn't be that difficult. Okay, read carefully. Hot dogs came in a pack of 10. What does that look like?
3 packs.
Why? Hot dogs came in a pack
Because
of 10.
never mind.
But okay, explain the 3. But you have something there. Why do you see 3 packs?
Because their least common denominator is 30.
It's coming in is 30. Okay. Why do you need 3 packs?
Because it says the same number of hot dogs as buns, and 30 would be the same. And how many packs of hot dogs did he buy would be 3, because they're, and then buns would be 5.
Okay, that's correct, by the way, because 3 times 10 is 30, 5 times 6 is 30. Go for it. But then we have to put that together for the total number of actual hot dogs. What is that?
30 hot dogs?
I think we have to put 30 because for it to work out, right? To have exact amount without anything left over. All right, let's check. I think you're brilliant. I think you're brilliant. You're thinking ahead right here. Good job, dude. Loving it. Good job, man. All right. 40 as a decimal. Okay, I assume you just use the calculator, right? That fast? Go for
No,
it.
I just multiplied it by 2.
Yes, because you can make a hundred out of it, right? Good job, denominator. Nice. Alrighty. Each year, Bill drives that much, 7,000. We'll plot them, but we got to get each row correct, right? Each year. Okay, 4 years. So we'll do 4 times 7. So that's going to be 28 and 3 zeros. And we'll plot them.
So
Yeah. Oh, wait. Put the number in the box first. I think they want that. Yeah, they want the A portion and then the B portion. And then 5, 6, and then 5, 6, and 3 0. Oh, yeah, you can do them. You can do them at the same time. 56,000. How do we even do that? Oh, yeah, it's there. Okay, I can see it now. 70,000. 7 0 and 3 zeros. 7 0 and then 3 more zeros. It's there. Yeah. All right. Nice. Okay. Write that as a decimal. Well, you know you can do long division. So let's just use the calculator to speed things up a little bit. So 29 divided by 6. Okay. But if necessary, use the bar. So put the bar over the very first three. So 4.8, yeah, 3 bar. Nice. Okay, remember these things again? Now, don't worry. Let's keep doing it until you remember how to do it perfectly, right? So it's, remember I was saying, well, first of all, you cannot use 15% as is. You have to convert it into a decimal. So it's going to be, a decimal number is going to be 0.15. Now, when you don't have the number right behind the word off, remember, you will have to divide. But if there were a number right behind the word off, you multiply that percent, well, the 0.5 to that number. So this time the A, you'll have to divide. You're going to divide 12 by 0.15. So you're going to go like 12 divided by 0.15 for A.
Uh,
But for B, you see the number off, the number right behind the word off, you will multiply directly. So it's going to be 0.45 times, I'll do X for times, okay? It's 40. So here's your A and your B. So kind of look at, see the difference? One divide, one multiply, but what you divide it by is going to be important, okay? The number uh, divided by the percent number, but converted percent number into decimal, right? Okay. Wait, I'm sorry. It's not in percent. The answer are not in percent. They're just 80 and 18, I guess. But I didn't use the calculator. I assume you already did. Yeah, take out the percent symbol. Okay, good. You'll get used to this, okay? No, you're going to see this again and again. All right. An item has a listed price of 50. If the sales tax is that much, how much is the sales tax? So it's a multiplication. You have to multiply your sales tax percent to the price that you're looking at. So it's going to be, but you got to convert your percent into decimal again. So it'll be 0.07, I think you would agree, times $50. And that will give you the sales tax only. So what is that? So yes, I agree. $3.50. Add on to $50. Imagine you're buying something for that percent sales tax. Okay, conversion. How many? Oh, hey, they're talking in ounces. Okay, and pounds. Okay, 1 ton is what? 2,000 pounds. You okay? Oh, it says it there. Okay, and then ounces. Or you divide, right? So 128 divided by 16. Do you agree? 16 pounds. 16 ounces equals 1 pound. There are 128 of those. So 8 pounds. Reciprocal of 4 is reciprocal. That's like the flip flop. Is another way of saying the flip flop of 4. So it's 1/4. Is that okay? 1/4 is the reciprocal. And this one, it'll be 8/1, but I don't think you need the 1, but you could put it in. It's computerized. Yeah, you can do it. There you go. So it's telling you, hey, you don't need the 1. But okay, this one, write the decimal in this, okay, in the sentence below as a percent. Okay. Oh, the A is only 43.7%. You only move 2 decimal places over to the right. So where it lands is, yeah. What about this one? Oh, it's 0.07. You got to move 2 places over to the left. Yeah, you need a placeholder. You okay? Yeah.
yeah.
Okay, good. So far, Heather, has poured that much millimeters of a liquid. She wants to pour a total of that much. How many more?
Subtraction.
Yeah, subtraction, but make sure the units, yeah, subtraction. The units better be the same. Yeah, let me do it. But it's already in millimeters, so we're just gonna go ahead and subtract the numbers as is. 0.2. All right, let's see. 32.8. Very good. All right, in 7 hours, Kira reads 28 chapters of a book. What is her rate in chapters? Okay, so this is called unit rate. Okay, I think you got this one. Yeah, 28 divided by 7. Yeah, good job. It costs this much for this many pounds of shrimp. Find the unit price. Dollar per pound. That means you have to have the dollar first divided by 3.5. Okay, you okay with that? So it'd be 14.63 divided by 3.5. It should be, okay, this is perfect because it's exactly 18 cents. Yeah, $4.18. Okay, good.